So I'm going to start from the very beginning because I think people are sort of all over the place. So if you go into the Jupiter's Moons Lab Part 1, you'll be able to read some of the general introduction stuff. In order to go through and see how you do things, you'll want to download the instructions so that you can look at that because I won't be able to stay on the screen the whole time. If you haven't already gone to the Google Drive folder and downloaded the images, you'll want to go through and do that. There's a spreadsheet inside of there that, although I think the name is different, I should change that. There's a spreadsheet inside of there that has your assignment as to which images you should be measuring. So you only need to download your images. You will not be able to open them on your own computer. You need special software to do that. So in order to open them, we're going to be using this link right here, which will open in a new browser tab. So this will allow us to view the images. Once we've gone through and done our measurements, you'll enter them into this Google form. So I'm just going to pick an image at random. So this is what the setup looks like. And again, we're following through the instructions here. Let me make sure that I can see them at the same time as you. There's various questions to answer along the way. So file open, local file, because they should be on your computer. So I just picked one at random. I have no idea if this image is one that you all need to do, and it's loading very slowly. So there's a few different things that we'll need to do now that we have this image in here. The first part of what you need to do in order to fill out the Google form is to see the FITS header. So FITS, this is the type of image like JPEG or PNG. So FITS is a different type of image. And FITS images contain a lot more information than normal images. So we want to go to display and then FITS header. So this is going to show us a bunch of the information embedded into the file. So you will need some of this to record into your Google Sheet. So the Google Sheet, for example, is going to ask for the time of the observation and this JD observation. So this is the date essentially of the observation. So normally we write date of observation with month, day, year. This is just counting days from some point in the past, so it's a very large number. So for this one, we can see that the image was taken here, and there's a note inside of the instructions that say the date is written as day, month, year, not the way that we normally do this. So that means if I go through, although years in the front, this is, actually that may have been fixed down in here. There. This is the day, month, year. So it's April 5th, 2016. So up here, this looks like it's written in a more familiar format from what you may be used to. So that is one piece that we need. The other piece that we need is the Julian date of exposure. So that's this number right here. You would put that into this part here. And then we need the time of the exposure as well, which I've seen in a few different places. So you could pull just this part of it, the 04/23/30, although there should be another specific time obs down here at some point here. This one right here, you could pull just for the time of the observation. So that is the information that's in the header that you'll need to do for each of your 5 images. Everyone has to go through and do 5. So the next part of what we'll fill into the form is for actually measuring the moons themselves. So if you go back to your instructions, it tells you how to adjust the image brightness and how to adjust the zoom so that you can go through and find all of the moons that you need. So I'm in a trackpad, so that may make this a little bit more challenging. We shall see. That means some of you may have similar issues. So I can click and move my mouse around, and that'll change the brightness a little bit. So now I've changed it so I couldn't see those moons at all. Now I can see them. So you can go through and make all kinds of adjustments to try and make things more visible and easier to see. I can also zoom out. So if I zoom out all the way, now I can see that there are, in fact, there were 2 right here. I have 4 moons in this image. So if I hadn't gone through and done the zoom, then I would not have been able to find all 4 moons that I need in order to complete this. So you'll need to go through and adjust your moons to be able to go through and do things. In order to go through and calculate the center, we'll need to go to the plugins area over here. And then we're going to click on regions and then select annulus. So regions here, region stats. Those are X projections. This is, oh, I picked the wrong one. Sorry, regions here. That makes more sense. Annulus. All right, so now it's gonna, the plugins is where it's gonna go through and show me my things. So I had already clicked close to Jupiter, and we can zoom in to be able to see this a little bit better. So if I click over here on one of these, it's gonna be a little bit harder to go through and do, and you can move this around to other objects. And so you want to try and get it as close to the one that you're interested in as possible. So with 2 together, that's going to be harder. Let's go back to Jupiter for right now. If I move it close to Jupiter, it's going to, I just need to get it as close as I can, and it will go through and find the center for me. So what I am looking for is the centroid X and Y position numbers. So this is in the region stats area here. So this centroid X and centroid Y, those are the numbers that I want. That's what I'm going to plug in for the Jupiter X position and Jupiter Y position. So 20, 48, 46 is my X position. I plug that in here. This is my Y position. See if it'll let me get all of it. No, I'll type the last number in. It's a little bit hidden. 1. And now I need to go through and do the different moons. So you essentially go through and repeat this for each of the different moons. Again, don't forget there were 2 that were further out. So if I zoom out, and then I can go through and click, not click, move it over to that one. It's going to center it for me, and it tells me the position of that one. So one of the issues with going through and doing this is trying to figure out which moon is which. So I encouraged you to go through, and when you get to this problem and aren't sure what's going on, send me a DM in Slack and I'll talk to you about it if you're struggling with trying to figure out which moon is which. So once you have your moons measured, the centroid for all of them, then you're going to use this equation right here to go through and calculate the distance between each moon. So these are the X and Y positions that we just measured from that centroid. I'm going to show you how to go through and do this. What I would like you all to go through and do is to mark down the numbers that we're going to need. So I'm going to put both of these into, no, I won't. So for Jupiter, the positions that we need are those numbers. And then for this moon, which again, we don't know what it is yet. And if you struggle with that, contact me separately. But that's the positions for the moon. So that way we can go through and refer to it while we're working. Okay, so I'm in a program right now that does math stuff for me, but if you have a calculator, you can use it. If you're familiar at all with the website Wolfram Alpha, this is essentially the desktop version of that same program. So what we need to go through is follow our directions to determine what that distance is. So I'm looking at the equation right above number 8 in our instructions. So the thing that I want to get is the distance to that moon. So I'm going to put this in for our, excuse me, measurements that we're working on. So I want the X position of the moon. I think I actually missed a digit there. Let's go back and look. Yes, I missed a 4. So the moon should have actually been 3/4 for the X position. Glad I caught that. So 1, 4, 4, 4, 9, 4. And then from that, I'm going to subtract the X position of Jupiter. So this is essentially going to give me the difference in pixels of the center of each of these objects, only in the X direction. And then I need to square that. Then I go through and do the same thing, but for the Y direction. Again, all still under the same square root. And truly the order doesn't matter since everything gets squared, but it's always good to have a standard practice. So we do the same thing for the Y centroid of the moon and the Y centroid of Jupiter. And then again, we need to go through, oops, I hit the wrong button. And square it. So the distance for this particular moon would be 670.574. This is all in pixels. So I would then enter that number into the Google Sheet for that particular moon. So that would go, if for example, this was Io, which it's definitely not, but if the moon we were dealing with was Io, then I would have put in the 1444.94 into the X position, the 2339.10 into the Y position. And then if I scroll all the way down, I would go through and put the distance we just calculated in here for the distance between Io and Jupiter. Now, some images, even when you zoom out and go through and do all your adjustments for brightness and things like that, will not show all 4 moons. If that happens, then you just put NA into the option so that it shows up in the spreadsheet as not being there at all. So that's how you go through and do the measurement part. Do we have any questions on the measurement? You'll repeat this for each of your 5 images. So you'll have one Google form submission for each image.